All right. All of you should have your calculator. Boy, are you going to need them for the rest of the chapter. None of these are going to be quickly done in your head. All of these will generally require a calculator. All right, close your mouths, listen up. I'm going to play this by ear. It's been a while since I've taught this class like as a non-honors, just regular. Every one of you can do as equally as well as you just did on that quiz on the rest of the stuff, but it gets really messy, the formulas. But if you remember what you just did, identify the shape, write down the formula, fill in the numbers in the right spots, grab your calculator, do the calculation. It'll work out fine, but you do need to really pay attention. So we just took our quiz. I mean, it's a lot. We still got 2 weeks before we even get to the test, right? And I'm already considering like we might have a practice day in between just to make sure we're good to go. All right, it will be a worksheet today. It's probably going to be a worksheet almost every day. The book just doesn't give us enough practice on the problems for me to be happy with it. Here we go. So today we'll be dealing with these things right here. As soon as we switch to 3-dimension, I have lots of students that, and it's not no fault of your own, but they can't look at a 2-dimensional shape, flat surface, and imagine the 3-dimensional shape. Okay? They can't look at the 2-dimensional shape of this and kind of figure out what am I looking at because it's on a flat surface. If you look on what's in front of you right now, all of those are 3-dimensional shapes, right? But you got to draw them on a piece of paper. So a lot of times your eyeball flip-flops around on you. You're like, wait, is it coming out at me or is it going away from me? Is it going left, right? If you ever during a test need to borrow one of my 3-dimensional shapes so that you can wrap your head around what you're visually seeing, they're right there on the shelf. Go grab it. Okay? Boy, are there a lot of formulas, right? Unfortunately for you, the formulas are confusing. And whenever you're given a formula sheet on a state test or NWEA test, they'll always say the same for this shape right here. It's a gazillion different shapes. They give you one formula, and it's not a very useful formula. You'll see here in a second. Here we go. Oh, here we don't go. All right, here we go. Problems really start today. There's a lot of new formulas. All right, think about this. If I had a perfect cube, right here is a cube, right? Rubik's Cube, what do you want to call it? Here's a cube, and the side lengths on all of the corners, because it's a cube, so all the sides are the same, was 1. We get a cube that's 1 by 1 by 1. Imagine a cube that's 1 by 1 by 1 by 1 filling up another shape. For instance, that shape, shoebox. You take those 1 by 1 by 1 cubes and you fill that sucker full of 1 by 1 by 1 cubes and count the cubes. That's this concept of volume. How many of these little tiny cubes does it take to fill up the shape, count the cubes? Hey, remember we did 2-dimensional? We took a rectangle, filled it full of squares. That's why the units for area is in squares, but the units for volume is in cubes because we're literally filling the shape full of cubes and counting them. Okay, so that's your first thing to write down, box 1, volume. It's the amount of space, not in 2 dimensions, that's area, but the amount of space in 3 dimensions, or 3-dimensional figure, sorry. What are you really doing? You're filling it full of cubes and you're counting. All right, volume is expressed in cubic units. You can write cubic units 3 ways. The word cubic, and then the units, or the units and a 3 above it, right? That's why we say cube the number, take it to the 3rd power. Good? One definition, that's it, in yellow. All right, so the rest of the chapter is we get a shape, I give you a formula, you calculate the volume. Okay? Unfortunately for you, there's lots of shapes. All right. The first shape we will do, they're all right here in front of us. Hey, can you see these? I don't know, maybe you can't. All of these are actually, every one of these, they all look different, but they're all the same shape. They're all prisms. Look at me. Here's the, right? A prism is made up of one shape. What's that shape? Okay, but I don't have one of them. I have two of them. You place those two shapes, this one and this one, parallel to each other, and you fill up the sides with, what is the shape? Rectangles. You take the two shapes. What are the two shapes? You make the two triangles parallel, and then you fill up the sides with rectangles. You take the shape, which is a, and you fill up the sides with rectangles. This particular rectangle is a square. Okay? That's what's called a prism. The problem for me when I was in 7th and 8th grade, this is all I thought a prism was this thing. Why? Because in science class, they take this thing and they shine a light through it and it makes a rainbow and they say prism. Right? They don't tell me about this thing, which is a prism, and they didn't, or I didn't pay any attention to the math teacher who told me that it's a three-dimensional shape made up of sides that are rectangles and the bases are common shapes. You get two of those. In this case, two hexagons. But it could be anything. It could be a triangle. It could be an octagon. It could be a dodecagon. I get two of them that are parallel and the sides are rectangles. That's a prism. Yeah, that is a prism. In science class, they literally shine a light through it and makes rainbows. Right? Have you seen that before?
No.
Okay. Yes.
What's a dodecagon?
Look it up. All right. You name the prisms, right? The clearly different looking shapes, so they must have different names. You name the prism by whatever the base is. What's the shape? Square prism. What's the shape? This is the worst one. The most common one. Rectangular prism. What's the shape? Triangular prism, and so forth and so on. Pentagonal prism. But once again, you get two pentagons, all the sides are rectangles. The one that causes problem is this sucker. Once again, you want to know why, Jenna? What does this look like to you? What does it look like to you? The kid that makes a mistake says this is a pyramid prism. What's the difference?
One has more sides.
They got triangles. What's the difference?
The sides are triangles.
What's the sides of this?
Triangles and one square.
What's the sides of this?
Triangles.
What's the sides of this?
Rectangles.
What's the sides?
Triangle.
What's the side?
A square.
That's not a square. That's not a square. That's a rectangle.
Okay.
Guy.
What? Looks like a square, but
All
squares are
rectangles.
That's the smartest thing I've ever heard you say. All right. Very good. All right. I'm going to tell you, look at this carefully. Right? She won't be, or you won't be the only one that makes a mistake. Other people, they will see this, and guess what formula they will use? They will use this. What are the sides? What's the shape of the sides? Look at it. What are the shapes of the sides? What are the shapes of the sides? Okay, out in the hallway, please. Wait for me. Okay. All right. Shapes of rectangle, or I'm sorry, shape of any prism are rectangles. Right? If you see a rectangle and it's the side, it can't be anything but a prism. All right. I don't like these. Because guess what all the sides are? There's no square here at all. They're all rectangles. All right.
But that's a square.
I didn't hold this one up.
I know, but like,
I didn't.
that's a square.
I didn't.
Rectangle.
That
Listen
is
to
a
me.
square.
A square is a shape
Yeah.
that has all sides the same. How long?
Not 6.
How long?
6.
How long?
You have it at the edge.
How long?
6.
Not 6.
6.
Right? Right.
Five, listen to me.
All right.
Where?
Now everybody stop what you're doing. I don't want to get too far off topic here. All right. So we name prisms by the bottoms. Right? The bottoms we're going to call the base, but here's the problem. Let me get this one out of the way. You see the bottom?
Yep.
Where's the bottom now?
On that side.
It's the base.
So when we say the base, we don't literally mean the bottom because I can take this and turn it this way. What we mean on a prism is we mean the two sides that are parallel to each other, right? There's only two sides here that are parallel to each other, triangles. That's why this is a triangular prism. Look, the sides are what shape?
That's a triangle.
The sides are what shape?
A rectangle.
Thank you.
Hey, but that was
Just stop. Okay. Hey, the two sides that are parallel are two sides that are parallel. Therefore, that's why that's called a trapezoidal prism, and so forth and so on. All right, write this down. You're going to have parts of a prism. You're going to have the bases. The bases are the two sides that are parallel. Okay, the sides are rectangles. Okay, the sides are rectangles. Now, the distance between the two parallel sides, what you name the prism after, is called the height. You got to be careful. We've been measuring the height vertically, right? If I turn it sideways, the height is now horizontal. It's the distance between the two parallel sides. That is always the height. The distance between the two parallel sides is called the height.
I know that's the base.
How do I know what?
That's the base.
The two sides that are parallel are called the bases. Okay. Now you got to be careful if you have a hexagon. I don't think I have one. A hexagonal prism, then you will get a couple parallel sides.
Wait.
What?
Where were we supposed to draw that?
No.
Oh.
All right. Now put your pencils down. Look at the board. Now we're going to talk about the calculation for volume. This is for any prism. Hey, what's the shape?
Triangle.
Triangle. If I took triangles and I stack them one on top of the other, I stack them one on top of the other, right? I would have lots of triangles. Can you calculate the area of one triangle?
Yeah.
Certainly can. So the formula for volume of any prism, I chose a triangle, it could be any shape. The formula for volume of any triangle, formula for any prism, for volume of any prism, now I got it correct, is we take the base, we calculate its area, and then what we do is we multiply that times how far it is from the bottom to the top. Now be careful, because I can take the whole prism and turn it on its side. But I'm still calculating the distance between the two triangles, the two bases. It's the worst formula ever written, right? I'm not even going to have you write it down yet. But the actual formula is you calculate the base area, you multiply it by the height. They are going to, instead of writing base area, they're going to put the capital letter B. Capital letter B means base area. H means the perpendicular distance between the two bases. I hate this shape. What's the base here? Any side. It's never a question with this one. It's never any question with this one what the base is. 9 times out of 10, when they have you do the calculation, they give you one of these. Any side on this one, and only this one in the cube, could be the base. Okay? So as you write this down, box 2B, I need to write everything you see on that slide down. Hoping I would get to that slide sooner, but it took a while.
Right here.
Okay, you still have an adult in the room. Yeah, you still have an adult in the room.
Hi, can you move your head a little bit? Right? Not like that. Thank you. Oh,
Sorry for that. Okay, so all we're going to do, and you're going to see this in every math book, it's big B times H. The problem is this is useless. What are you going to do? Big B times H. I don't know. That doesn't help me at all. So what we have to do, height is pretty easy, distance between the two bases. What we need to do is we need to talk about that sucker right there. That's the base, and it stands for base area. So we need to calculate the base area and multiply it by the height. If you open up our book, every single time you get to a prism, they just say, oh, just use BH. Nobody, that doesn't help. I'm going to give you a formula for every one of these shapes. So even though it's a prism, even though technically it's one formula, it's actually 1, 2, 3, 4 bunches of them. All right, here we go. Hey, what's the shape?
Rectangle.
So what's the base shape?
Rectangle.
It's a rectangle. So what's the formula for a rectangle area? Or length times width, right? Therefore, this one turns into all rectangular prisms, whether it's a cube or whether it's a rectangular prism. All rectangular prisms end up being the base, top or bottom, doesn't matter, right? Useless formula. What's the shape?
Rectangular prism.
And the formula for area of a rectangle is
Base times height.
more length times width. So I'm going to take length times width times height. Write that one down. That is the formula for a rectangular prism or a square prism. Length times width times height. That is the useful one. Okay, great. Capital BH. Thank you for giving me nothing. Right? Now we're going to do length times width times height. By the way, it's the easiest one to calculate because there only are ever going to be 3 numbers here. It doesn't matter if I fill in all the sides. If this side is 10, that side is. That side is 10. The back one is 10. If this side is 3, that side is. And that side is 3. And the one you can't see is there's only going to be 3 numbers. Everybody gets rectangle and cubes. Length times width times height. Boom, done. Yes?
Yeah.
Box 3, length times width times height. There's only 3 numbers there. It doesn't matter if I had them all filled in, there would only be 3 numbers. If it's a cube, how many numbers will there actually be?
One.
There'll be one number because all the sides, all the corners, all the edges are the same.
So you're saying, wait, that one right there.
Okay, you need to get your head off of that right now. All right, length times width times height, 8 times 4 times 7, and you're done. Okay, multiplication is commutative. It doesn't matter the order that you multiply in. Okay, questions on rectangular prisms? Is it about that math?
I have a question.
Is it about this math?
I just have a question.
Is it about this math?
No, I'm
Okay, keep it to yourself.
What is.
Keep it to yourself. All right, are we good for rectangular prisms?
Yeah.
All right, moving on to the more challenging shape. Okay, this sucker right here gives every student in 8th grade problems. What's the shape?
Triangle.
What's the formula for area of a triangle? Divided by 2. The problem with that is base times height. You get an h for the height of the triangle, but we also get another h. You get 2 h's floating around this formula. So here is the issue, box 5. Do you see the triangular prism? Not a pyramid. The sides are rectangles, not triangles. This is not a pyramid. This is a prism. The issue is this. Can you see the triangle? Let me make it colored for you. You see it?
Yeah.
So we got a base and we got a height, yes? What do we call 25?
Base.
No, depth.
We don't. We call it height. That's the issue. Is we got a height here of 20 and we got a height here of 25. They didn't. That would be nicer, but they didn't. They call both of them height. So that's an issue of confusion. Remember, the definition of height of a prism is the distance between the two bases. The bases is not the bottom. It's whatever 2 you have. I got 2 triangles. Those are the 2 bases. If I stand it up like this, great. Base, bottom, base, top. If I turn on the side, like this one, the bases are still the triangles. And the distance between the 2 triangles, 25, is the height of the prism. So I got this height and I got this height. So when you write the formula right now, that's what it looks like. For a triangular prism. 1/2 base of the triangle times height of the triangle, that's just the area of the triangle. Now we have to multiply that whole thing by the height of the prism, and there's the full formula. It is ugly. 1/2 base of the triangle times the height of the triangle. That gives me the blue area. And the distance between the 2 triangles is the height of the prism. I got 2 h's. They're not the same. They're different. Landon.
So couldn't you just do base times height only?
But if you can't say height times height, what does that mean?
Height triangle.
Well, that's why I wrote it. So what's the difference between what you said and I said? Nothing.
Wait, so 25 would be a height?
A height of the prism. Because remember, the definition of height as a prism is the distance between the 2 parallel sides. If I turn it like this, the height doesn't go up and down, it goes left and right. If I turn it like this, the height does go up and down. Hey, look at my triangles. I got it turned on its side. So the height of this prism is between the 2 triangles. If I take it like this, now we get what we'd like. Now height does go up and down. All right, does everybody have the formula written down? Good. It's a Friday, we don't have a lot of time, but I need to get those 2 formulas out of the way. All right. The calculation, though, is pretty standard. It's 3 numbers multiplied together divided by 2. Okay, 3 numbers multiplied together divided by 2. 3 numbers multiplied together divided by 2. But here's the thing that will kick your butt. How many sides on a triangle? How many sides on a triangle? 3.
Oh,
How many sides do I have listed on this triangle? Where are you getting those numbers from? How many sides do I have shown with numbers on my triangle? 1. There's only a 12 there. This side doesn't have a measurement. This side doesn't have a measurement. So guess what they're going to do tonight for homework? They're going to put those numbers in. Does that help you or hurt you? It hurts you because they're going to give you information you don't need. If this side is 12 and the distance between the top is 20, maybe this side is 22, and maybe this other side is 21. You're going to have numbers floating around that you don't need. I need a base and I need a height. Your eyeball finds the little square. Remember, the little square on the triangle touches the base and it touches the height, unless it's that weird scaling up to one. Okay? All right. That's where I generally see the problem. The problem is that they're going to throw lots and lots and lots of numbers. Like this one. You see it?
Yeah. There's only.
They gave me all three sides of the triangle. I just need the base and the height. That's it.
And the base would be 4, right?
The base is 4. The height is
8.
Where are you getting 8?
Because you said
We're talking about the triangle. The formula says base of the triangle times height of the triangle. Look at the triangle first. So if the base is 4, what's the height? Well, what's the height of the prism?
8.
Now you got it.
Okay, that makes a lot more sense.
What about the 5?
It's just extra information. It's not wrong. It's just information we're not going to
Could you
use.
not state that? This is base.
What? I can't, because remember, base, if I make this the base, then I need the distance between this side and the opposite vertex for that to be the height. If they gave me that, yes, then 5 would be the base. But where's the squared? The square is touching the 3 and the 4, so that's your base and the height. Yeah.
Would dashed lines be height?
Usually, always, at least in the book, and when I give you something, it's usually dashed. Yeah.
No.
Well, remember, we have 2 heights. You got to tell me which height do you want. Do you want height of the triangle or height of the prism? The height of the triangle is 3. The base is 4. The height of the prism, though, is 8.
Oh, okay, I get it. Kind of. Oh, no, I get it.
We okay?
Yeah.
All right.
Very
We take the numbers, and notice I'm focusing more on the formula than I am on the calculation, because the calculation is multiply the 3 numbers, divide by 2. 4 times 3 times 8, 12, 96 divided by 2 is 48. Okay? We okay?
Yeah.
Yes.
I got 60.
4 times 3 times 8 is what?
I did 3 times 5.
Where do you get a 5 from?
No, don't use that.
Where does the square touch?
Don't use it. Pretend it's nothing.
Oh, so it's 4. Okay.
That's the mistake. Okay. Notice here, I'm not giving you any extra information. I'm just giving you exactly what you need. Okay? I'm giving you the base of the triangle, the height of the triangle, and the height of the prism. So if they only give you the numbers that you need, it's hard to screw this up. You will screw this up 2 ways. If you think it's a pyramid, you're like, well, how am I ever going to mess that up? You will. I see it every year. Pyramids have sides that are
Triangles.
prisms, have sides that are
Rectangles.
rectangles. But when I put it like this,
They look.
I will literally have people say this is a pyramid. I don't understand why, right? Because if you kind of squint, maybe it does look like it's not a pyramid, because the sides are rectangles. All pyramids, no matter what kind of pyramid you have, there's multiple kinds, the sides are triangles. All prisms, no matter what you have, the sides are rectangles or squares, because all squares are rectangles, Smalley told us correctly. All right. Could you do this by yourself?
Yes.
All right.
Well, so 10 would be
Height of the triangle. 12 would be the height of
prism.
here's the cool thing. What are we doing? Division or multiplication? Doesn't matter the order you multiply them in. What will matter is on the previous one, when I give you extra information, the 5. Yeah, then you screw it up. Or you look at the shape and you say, I see a pyramid. And you use the pyramid formula. Anybody know the pyramid formula off the top of your head?
No, I don't remember.
You will on Monday. All right. Or maybe it's Tuesday, one of the two. Yes.
Why is it that when you have it, it has a cute bug?
Where you are?
Okay, I can't hear what you're saying because he's talking.
Why
What?
does it say it's cute?
Because literally volume is how many cubes can you fit inside the object. That's the definition of volume. How much space is inside an object when
So-
those filled up with cubes
So it would be 12 times 4 times
divided by 2.
divided by 2.
But I would rather you remember its base area. In this case, it's a triangle, so 4 times 10. Okay. Times your 12, then divide by 2.
That makes
All right.
sense.
This becomes slightly confusion tonight for homework on the thing where they give you both shapes and you have to switch back and forth. Do you see how it's drawn?
Yeah. Yes.
The problem with this is that it's not 3 dimensions, it's 2 dimensions. So as you stare at this enough, sometimes your eyeball causes it to come out at you. Sometimes it causes it to go sideways. Sometimes it, like the bottom triangle here, is it below? Is it above? Is it coming out at you? You can look at it many different ways. Sometimes it looks like this. Literally, some people see this shape. Some people see this shape when they're staring at that. And that can cause problems. And it's because you're drawing 3 dimensions and 2. So that can cause you problems. Hey, what's the base of the triangle there?
9,
What's the height of the triangle?
6,
What's the 7 and the 8?
extra number.
Extra numbers.
It's sides of the triangle. It's just extra information. What's the height of the prism?
10.
You have all 3 numbers. You can do that easily. We like this rectangular prism because there's just 3 numbers, 6, 7, and 5. No matter how many extra sides they label, there's always going to be 3 numbers.
Okay, so I
It can
got
become slightly confusing when there's a square involved because then maybe you only have 1 or 2 numbers.
okay, so I
What?
got a question. It's 6, so I see that 5 is the base as well, so
Focus on the base, top and bottom. What do you see?
6.
6 times 5 is 30 times the height, which is 7.
Okay.
Okay.
That makes a lot of sense.
The only thing about rectangular prisms is that you can actually use any 2 opposite sides as your base. So if I didn't want to use top and bottom, I could have used left and right, but they weren't labeled nice for me. Yeah.
How did you get 180?
Well, I didn't do that one. I was talking about these 2. Okay. A square prism has only one measurement. What's the measurement?
6.
What's the only measurement?
5.
A square prism measuring 6 along each edge, so each side 6, right? It's 5 tall though. So the base is a square, but the sides are rectangles, right? It's not, notice I didn't say I have a cube, it says I have a square prism. That means the bases are squares. That doesn't mean that the sides are square. It could be if it's called a cube. But if it's called a square prism, the only thing you're guaranteed is that the bases are squares. The sides could be rectangles. Hey, what's the shape?
Rectangle.
Okay, that's a rectangle. That's a rectangle. That's a rectangle. That's a rectangle. It turns out that's actually here's a square prism.
Really?
If I hold it this way, I have a square prism. Hey, top and bottom are squares. If I hold it this way,
Rectangle.
rectangular prism. The side squares are still rectangles, right? But if I call that the base, which they did here, this is a rectangular prism. Don't get hung up on squares and rectangles other than pyramids, sides are triangles, prisms, sides are square rectangles. That makes sense. All right. We good?
Wait.
What?
Oh, no.
6 times 7 times 5 is 120.
Yeah, I thought it was.
All right. Last idea is this. They're going to give you the words, no picture. What's the shape?
Rectangular.
And no, you don't have to draw it. You just got to do the calculation. What's the formula for a rectangular prism?
Weight times height.
Okay. If you'd like to draw it, draw it. It says the length and the width, that's of the base, would be 3 and 4. It says the height. Oh, it doesn't say the height. So that's going to be my X, or you could use H if you wanted to as well too. But I do know that the volume is 96, so I do some basic algebra. I'm solving for H. I plug in what I know. I know the volume was.
96,
I know the length was.
3, 4,
I know the width was. What I don't know is
length, height.
height. The formula is length times width times height. Could you solve this algebraically?
Yes.
3 times 4 is.
12.
Now what do we do to both sides?
9 times 12.
Okay, so you could solve this, right?
Well, we need to divide by 2. Boy, it must have-
Not on this formula. Okay, the divide by 2 is on the triangular prisms. All right, if this was it, and by the way, this is it for 7th grade. We did do this last year. If those were the only 2 shapes, life would be good. Unfortunately, those are the 2 easy ones. We come to the more challenging ones, the pyramids, the cones, and the spheres. All right.
So what is sphere? Would be
Homework is your sphere is a weird formula we'll talk about when we get there. All right, on your way out, grab worksheets. Hand it to me on your way out. Right there.
Mr. C, what is the homework for tonight?
It's a worksheet.
It's worksheet. You'll see it on Teams.
Okay.
Bye, Donovan.
Bye, Donovan.
Bye, guys.
Donovan down in the lobby the other day.
What?
Down in the lobby.
You guys playing basketball?
We are playing. We're playing Caden's brother's school. What is it called, Caden? Caden, what's your brother's school called?
Pretty sure CMA.
Oh yeah, we're playing CMA.
Is that where your brother goes?
Yeah, that's his brother.
I found a lemon salt
Is he gonna be
packet, I
fine?
guess. No, I found a lemon salt packet, I guess.
Thank you.
Don't forget, I will never forget.
Hey, what, Jaden? Can we make it cold in here? We just got out of PE. And I play volleyball the whole time. And it didn't work out.
Why is that we're only sitting for the
It's
half?
over. You said we
I
can
said
make
it
it
wrong.
colder. Yeah, I was.
Why is everyone running for?
Giving you plus on the test.
We have a test?
Yes, sir.
What? Yeah, we have a test. There's no test. There's no test today. There's no test today.
And but there are also some other people who say that there's only one student.
Really?
Is there a test today?
No, I don't think so.
It's on Tuesday.
Oh yeah, guess what? I forgot my freaking math book at home. I'm an idiot. Yay. I don't have a water bottle. You forgot it. Yeah, well, I left my math book at home.
This water bottle will live in you.
Somebody else needs to play fake calories.
I hate this.
Sir, yeah, don't be talking and have to say
Clean up that mess.
I think you're still alive, Bailey. Man, lost a little bit.
I saw you still.
Yeah, just a little bit of blood, not that much.
I left my math book at home. Very funny.
Carson, the water bottle will live its tail.
Awesome.
It already died.
I wanted my freaking math homework.
That's why you know
Macy, what?
Is there a test?
Yes,
No, wait, what?
big one. We're 1/2 of your final grade. Remember, it's been on the calendar the whole week, right? I've been talking about it every day.
Yes, that was the other.
Yeah, you guys
You really don't remember? Right, because I never said it.
Oh,
Okay.
Why would you ask if there's a test today?
I didn't see there was a test.
Why do I show in every single class the calendar?
I left my math notebook at home.